All right, welcome back. We're going to take a look at trig ratios today. We'll define them, sine, cosine, tangent, as well as their reciprocals, cosecant, secant, cotangent. And we'll find the values of a right triangle given two sides of that triangle. I like this little introductory statement here. There's a lot of applied problems that require the use of triangles, especially these right triangles, such as forces acting on objects, air navigation, surveying, projectile motion, light refraction in optics, and so on. So we'll do a few, but let's go ahead and define them first. As you might recall, a lot of people remember SOHCAHTOA for sine is opposite over hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the ratio of the opposite over the adjacent. SOHCAHTOA, SOHCAHTAH. I actually learned it as, sine is O heck, cosine O heck another hour of algebra. Oh heck another hour of algebra. That's how I learned them, actually. I've never forgotten them, but so let's look at the triangle as far as who's opposite, who's adjacent, and so on. If we put this theta right here in this bottom left corner, then the side opposite is one of the opposite and the adjacent are the legs, okay? So the legs are the right next to your right triangle, but that's the opposite side. The adjacent side is next to, that means next to. So here's your adjacent. And then the hypotenuse is always opposite the 90-degree angle. That's where your hypotenuse lies. Now, if we do, let's say I have a different triangle, and let's say I put let's do a different right triangle. And this time, let's put the theta up here in the upper right corner. If the theta is in the upper right corner, then the side opposite would be here. Here's the opposite. The adjacent is the leg right next to it. And opposite the 90 is always the hypotenuse, right? And let's go ahead and find, and we should mention, don't forget too, that for a right triangle, a squared plus b squared equals c squared, right? That also has that relationship. Now let's look at, so that's sine, cosine, tangent. The sine is defined as opposite over hypotenuse. So cosecant, so here's how I remember. S goes with C. Cosecant flips it over. Instead of opposite over hypotenuse, it flips it over. It's hypotenuse over opposite. C goes with S. So secant is the reciprocal. Instead of adjacent over hypotenuse, it flips that over. Hypotenuse over adjacent. And then tangent and cotangent. Here's your cotangent. Just flips over. Instead of opposite over adjacent, it's adjacent over opposite. So let's go ahead and find all 6 trig functions here for both angle A. So let's do it first for this angle A. So angle A right here, here's our theta. Or it's angle A, we'll just leave it as angle A. So the sine of angle A, O heck, opposite over hypotenuse. Cosine of angle A would be, again, this is angle A. Adjacent, oh heck, another hour, adjacent over hypotenuse, or SOHCAH, C-A-H, TOA, T-A-H, SOHCAHTOA. Tangent would be adjacent over hypotenuse. So let's go ahead and fill this out. For angle A, the opposite side would be the 3. So here's my opposite. So the adjacent side would be right next to it, right here. Here's the adjacent side right next to it. And the hypotenuse is opposite the 90-degree angle. So the sine of angle A would be, so the sine of A opposite would be 3 over adjacent. 3 root 3. Now really, we should simplify this. So 3 over 3 is 1. So we got 1 over root 3. And really, we should not have a square root on the bottom. So let's go ahead and rationalize that. So we'll multiply top and bottom by root 3. And we'll get root 3 over 3. And so the sine of A is root 3 over 3. Okay? Let's do cosine. Cosine of A is adjacent over hypotenuse. So now we're going to go adjacent over hypotenuse. So 3 root 3 over 6. 3 root 3 over 6. Now 3/6 is 1/2. So I have 1 root 3 over 2. There's the cosine of angle A. So cosine of angle A is root 3 over 2. So we have the sine, we have the cosine. Now let's do the tangent. Tangent would be adjacent, oh heck, another hour of algebra. Whoops, I wrote that wrong. I'm sorry, guys. Of algebra. Good grief. Opposite over adjacent. Sorry about that. Of algebra. So it would have 3 over 3 root 3. Opposite over 3 root 3. And I just realized I just did, gosh dang it, I did my sign wrong. Oh heck. Oh heck is opposite over hypotenuse. That's my sine. I'm so sorry, you guys. Sine is opposite 3 over 6. Good grief. Making a mess. Sorry, it's opposite over hypotenuse. 3/6. So there's my 1/2. So sine of A is 1/2. Gosh dang, sorry about that. Alright, so this one, let's keep going with the tangent. 3's cancel, I got 1 over root 3. I got to rationalize that. And so we have root 3 over root 9, which is 3. There's our tangent of A. Okay? Now let's get into their reciprocals. So the sine, notice we have the sine. Let me erase a little bit of this. So the reciprocal of sine is a cosecant. The cosecant would be hypotenuse over opposite. The secant would flip over the cosine, so hypotenuse over adjacent. And the cotangent flips over the tangent, so adjacent over opposite. Okay, so cosecant, let's do that first. Hypotenuse here would be 6 over the opposite would be 3. So 6 over 3, which is 2. Remember, the sine was 1 over 2, so 2 over 1, right? So cosecant's 2. Secant's hypotenuse over adjacent, so hypotenuse over adjacent. So 6 over 3 root 3. Well, 6 over 3 is 2, so I got 2 over root 3. But remember, we can't have a square root on the bottom, so let's go ahead and rationalize that. So we end up with 2 root 3 over 3. There's our secant. Cotangents, instead of opposite over adjacent, it's adjacent over opposite. So 3 root 3 over 3, and the 3's cancel, so I have root 3. Okay, so that's all the trig functions for angle A. Now it does ask us to do it. What if we change that to angle B instead? How does that change things? Instead of angle A, change this to angle B. Erase this here real quick. Alright, so now angle B. Instead, oh heck, another hour of algebra, but now angle B is up here. So angle B is up there, so the side opposite would be that 3 root 3. Here's opposite. And the side adjacent, right next to it, the leg adjacent would be right there. That would be the 3. And the hypotenuse stays the same. It's always opposite the 90 degree. So the sine of B, sine of angle B, would be opposite over hypotenuse. So 3 root 3 over 6. Well, 3/6 is 1/2. So I got √3 over 2. And there's the sine of B. That's the sine of B. Cosine of B, adjacent. That'd be adjacent over hypotenuse. I have 3/6 or 1/2. And now let's do tangent B. Tangent B would be opposite over adjacent. So 3√3 over 3. And the 3's cancel, so we have √3. And remember the reciprocal functions. So the reciprocal sine is the cosecant of B would be hypotenuse over adjacent. So instead of opposite over hypotenuse, it'd be hypotenuse over opposite. Hypotenuse over opposite. So 6 over 3 √3. And 6 over 3 is 2. So I have 2 over √3. Rationalize that. So I have 2 √3 over 3. Cosine of B's reciprocal would be the secant of B. So instead of adjacent over hypotenuse, I'd have, instead of adjacent over hypotenuse, I'd have hypotenuse over adjacent. So 6 over 3 instead of 3 over 6. I have 6 over 3, which is 2. And finally, tangent's reciprocal will be the cotangent. Cotangent B, instead of adjacent over instead of opposite over adjacent, it's adjacent over opposite. So 3 over 3 √3. Well, the 3's cancel, so I have 1 over √3, but then I got to rationalize that. So I have √3 over 3, and that would be our cotangent. So for this one, it looks like they give us a couple of the side lengths. Now, whenever you're, just to make a note here, if you have a right triangle and they have A, B, and C, it's pretty typical that you put the lowercase is typically your hypotenuse, and it's opposite. See how it's opposite the 90 there? And then lowercase a would be side length opposite angle A. Lowercase b would be side length opposite angle B. See how that's labeled? So that's pretty typical. This one's already labeled for us here. And then they give us a side length. They say this is 1.7, B is 1.8. Notice they do not give us C. So we got to find C, right? What is C? Well, if you remember, Pythagorean theorem says the sums of the squares of the legs of the hypotenuse is the square equal to the square of the hypotenuse. So A is 1.7, it'll be squared, B is 1.8, it'll be squared equals C squared. Well, 1.7, let me punch that in. 1.7 times 1.7 gives us 2.89. 1.8 squared, 3.24. So those give us 6.13. So C squared equals 6.13. Make sure you square root both sides. And that'll give us 2.475883681. We'll take that. How about we'll take that to 2.476. We'll round it to the nearest thousand. So C, now we know C, 2.476. And now we can answer, with that information, the sine of A. Sine of A. Well, if you remember SOHCAHTOA or OHEC, right? Sine of A. So if A is here, the side opposite would be what? Be the side opposite be 1.7. That'd be the side opposite. And then the hypotenuse, of course, is that 2.476. So sine of angle A would be 1.7 divided by 2.476, 0.68659. We'll round that. How about 0.69? We'll leave it right there. They also ask us, though, to do tangent of B. So tangent of B Oh heck, another hour of algebra. Or SOHCAHTOA. TOA. Tangents opposite over adjacent. TOA. So the opposite side of B. So now I'm looking at B. All right, B is up here, right here, in the upper right. The opposite side would be right there, the 1.8. The adjacent side would be that 1.7. So the tangent of B would be 1.8 divided by 1.7, or 1.0588. Let's round it to 1.0459. And that's tangent of B. All right, this last example, so forget about that one for a minute. It says if tangent of A is 5, let's go ahead and draw this triangle. Let's draw it up here. I'm going to label it A, B, C. This will be my 90. So lowercase c is opposite angle C. Lowercase a is opposite angle A. Lowercase b is opposite angle B, capital B. So the lowercase b would be down there. And now if tangent of A, remember tangent is TOA, opposite over adjacent. Oh heck, another hour of algebra, if you want to remember it that way. Is opposite over adjacent. And they tell us it's 5. Well, 5 over what? Well, if it's 5, it's got to be 5 over 1. So the opposite side must be 5 of angle A, right? This is angle A. So the opposite side here, the adjacent side would be here, and the hypotenuse, of course, is always opposite the 90. So opposite would be 5, so this is 5. Adjacent would be 1, so they're giving us 2 side lengths. And it says find sine of A. Well, the sine of A is opposite over hypotenuse, so I need to know the hypotenuse side first. So let's go ahead and solve for the hypotenuse. So we know A squared plus B squared equals C squared. 5 squared plus 1 squared equals C squared. 25 plus 1 equals C squared. 26 is C squared, square root both sides. So we got square root of 26 is our C. Let's go ahead and write that up there, whatever the square root of 26 is. 5 point something, right? Now let's go ahead and find the sine of A. Well, again, A's here. Oh, heck, or SOHCAH. S-O-H, SOHCAH. So it would be opposite side, 5, over hypotenuse, which is root 26. Well, we got to rationalize that. Can't have a square root in the bottom. So let's go ahead and multiply by the square root of 26 on both sides. So we got 5 root 26 over root 26 times root 26 is 26. So there's our sine of A. All right, that should kind of get you guys started. Let me know if you have any questions.